Welcome to Pomodoro Joe for Saturday, June 24th, 2023. Today we're looking at LeetCode problem 956, tallest billboard. This is a hard problem. And again, I don't have a lot of time today, so I might do this one a little bit differently than usual. So in this, we are given a list of rods. Now our goal is to build the tallest billboard we can. But the caveat is the billboard has to have two legs or two supports of equal length. So we just have a list of rods. We need to create the tallest two supports we can out of this list of rods, sort of by stacking these rods together. If we're not able to build any billboard, if we can't find two equal height lengths that we can create out of these rods, then we return 0. All right, now we're given some constraints down here. It looks like we have the rods up to length 20, and we have up to 1,000 rods. So this could take a lot of time. All right, so my initial thought on this one is to go recursive. However, I also think recursive is probably not going to be fast enough. But let's put 25 minutes on our Pomodoro timer and we will get started. All right, so for this one, I will be using a result, set it equal to 0 to start, and we will return our result at the end. Now this recursion will be a little bit different than other recursions in the sense that we're passing our result down all the way and we'll just return at the end. We won't be sort of returning that result back up to previous calls. So with recursion, you're usually asking for the result of some subset. So you'd say, give me the maximum result from this subset. However, in this case, adding one rod to either the max length of either side of the maximum billboard doesn't give us a new maximum size billboard because now we have unequal length rods. So this is a little bit different than our normal recursion. So let's see. So we have our tallest board recurse. We need to know which rod we're currently on, so that's the index. And then we'll have the height of our left pole and the height of our right pole. Now, what are our options? Well, we can not use this rod at all, or we can add this rod to the left pole, or we can add the rod to the right pole. Those are our options. Now, one thing here, I do need to grab this result. And it's a non-local result. We could be passing it in as an argument each time, but I'll just make it non-local. So that means we can actually access this result from inside this function. All right, let's do our base case first. If our index is greater than or equal to the length of our rods, we're outside the bounds and we can just return. Now we're not returning anything at all. In this case, we're just returning because we're actually going to be updating our result as we go. Okay, so if we're outside of bounds, we just return. We are done. No more recursing. All right, what are our other options? Well, we have a new left, and that's going to be this rod at index. Let's see, let's actually grab this value out here. So this rod will be rods at index. So our new left will be this current left plus the rod. And our new right, that's just our current right plus this rod. Now we have to check, did adding this rod to our left or right cause our two poles to be equal size? If it does, then we have a new result. So if the new left is equal to our current right, that means now we have an equal height. We can add this to our result or check to see if this is better than our current result. So if they're the same height, then our result will be either the maximum of our current result or this new height. Same thing for the right. So now we've got our cases where we're equal of height, and now we need to do the recursive cases. So we have 3 recursive cases. Ooh, that is a lot. So essentially you can think of this as a tree. Now at the root of the tree, there'll be one case. We have 0 index, 0 left, and 0 right. That is our starting state. But then from that root, we have 3 branches. One that will add to our left, one that will add to our right, and one where we don't add the rod to either the left or the right. So that's 3 children from this node. Next, each one of those nodes will have 3 more children, and each one of their nodes will have 3 more children. So this is going to grow very quickly. Okay, so we have three options. Don't do anything. So index plus 1, we just go to the next rod, but we pass through our left and right. The next option, we go to the next index, but with the new left and our current right. And finally, we can go to our next index with the current left and the new right. Whew. Okay, it's not too much code, but there's a lot of things going on in here. 3 recursive calls. This is not looking good. All right, and now we do need to call our recursive function for the first time. And we'll pass in 0 for the index, 0 for the left, and 0 for the right. Okay, let's give this a shot. All right, so this works, but it's going to be very slow. I'll submit this, but I don't think we have a chance of passing. And we don't pass. We only beat 7 out of 80 test cases. That is not good. So we'll add this test case to our list here. Now we need to come up with a new approach. So one thing with this approach is, well, actually here, we can try something super simple. We're just passing in an index, a left and a right height. These are all very simple arguments. So we can try caching. This might get us a little bit further. So let's try this. So if we cache our result, we might do a little bit better. But one thing I will point out, oh, even that doesn't work. So our caching doesn't get us far enough. So this left and right. Now the position of these poles doesn't really matter. They don't tell us that one pole has to be on the left and the other has to be on the right. They're going to be of equal heights. So if we had a left of 10 and a right of 20, that's the same state as a left of 20 and a right of 10. But we're actually going through all the different permutations. And so having the same state in duplicate just on left and right sides is actually an inefficiency that we need to correct for. So let's get rid of this whole thing. Let's start this whole thing over. So for this, we'll be using dynamic programming. And instead of having a left pole and a right pole, we'll actually have a taller pole and a shorter pole. Now they might swap left and right, but it doesn't matter. We don't actually keep track of left and right at this point. We don't care if there's a left or right. We just care that there's a taller pole and a shorter pole. Now this one does have a trick, and I'll point that out here. I did not come up with this trick, so I can't take credit for it. The trick here is to keep track of our state. Normally you'd keep track of 2 pieces of state, your left pole and your right pole, or your shorter pole and your taller pole heights. Now, in this case, we're going to keep track of not those 2 states, the height of the short and the tall pole. We'll just keep track of the tallest pole for a given delta between the tallest pole and the shortest pole. Let me explain that again. So instead of keeping track of 2 heights, the short pole and the tall pole, we'll keep track of just the tallest pole and the delta between that tallest pole and the next shortest pole, or the short pole. Okay, so we'll have a dynamic programming dictionary. In our dynamic programming dictionary, the key will be the delta between the poles. So at this point, we don't care what their heights are. We just know there's a delta. So there's a delta between the poles, some difference. The value will be the tall pole value. Now we can find the short pole's value by just taking the tall pole's value and subtracting that delta. Then we can find the short pole value. Now, I guess the key to recognize here is what we're looking for is a delta of 0. Now, when we have a delta of 0, that means both the tall and the short are the same height. So with a delta of 0, and we're keeping track of the tallest value for that delta, that means at a delta of 0 with that tallest value, we've got 2 poles of that tallest value. And that will give us the tallest billboard we can build. All right, so we will have some dictionary here. Now the key will be the delta, or the difference, between the tall pole and the short pole. Now the value, now we do want to keep track of the tallest pole we can build that has a delta of 0. So in our case, We'll be keeping track of all the deltas, but we're looking for the delta of 0. So the value will be the tallest pole height. All right, so our DP here is a dictionary, and we'll start it out with 0, 0. So there's 0 height for the tallest pole at a 0 delta is 0 at the start. Now, one thing is I'm not using a default dictionary here, and there's a reason for that. If I use a default dictionary, it's going to complicate things later on because we do need to actually keep track of snapshots along the way, and making copies of default dictionaries sometimes can present problems. So I'm just using a standard dictionary in this case. All right, so our next step is to go through all of the rods. So for every rod in our rods, once again, in our previous example, we could add it to the left or we could add it to the right. Now in this case, we can add it to the short or we can add it to the tall. Now we do need to know, well, what are our options? So our options for all the different short and tall poles will be in our dynamic programming dictionary here. So at this point, we'll go through all of the previous poles, all these dynamic programming key value pairs, and we can either add it to the tall or we can add it to the short. So for example, for every, I'll call it delta. So this will be the difference because we're storing the delta as our key. For every key, maybe I should just call it key and make it easier on you. Yeah, I'll do that. For every key in our DP, that makes it clear. So if we're going through every key in the dictionary, our delta is the key, as we described up here. That's the difference between the poles. Now our tall, I'll call it taller. So the taller is just the value of our DP at this key. Now the shorter, well, we know that we have a delta and we have the taller, so that's just the taller minus this delta. Now we have a taller and a shorter pole. And now we can add the rod to either the taller or the shorter pole. So I'll have a new taller pole. And that'll just be the taller plus the rod. And we have a new shorter pole. And that's just the shorter plus the rod. All right. And I will actually space these out because we have a new taller pole. We'll also have a new delta between the new taller pole and the shorter pole. So let's call that new taller delta, or maybe new taller key. I'll call it delta. So the new taller delta, well, that's this new taller pole minus the short pole. What about this new shorter? Well, the new shorter delta is a little bit more complicated. So the new shorter delta, well, we added this rod to the shorter pole. This might still be shorter than the tall pole, or this might be taller than the tall pole. Let's do that. Might be taller than taller. So if that's the case, then our delta isn't as straightforward. We can't just subtract the shorter pole from the taller pole. We might end up with a negative delta. So in this case, we actually need to take the absolute value of the difference between the two. New shorter minus the taller. All right, so now we have our new taller pole, the delta, the new shorter pole, and its delta, and the deltas are just the keys into our dictionary. Let's update our dictionary at this point. And this is where it presents another problem, but let's just see what we would do if we could do it. So our dictionary now for the new taller delta. So we're updating the new taller delta. Now we want to choose the tallest pole that has this delta between it and the shorter pole. Now we might already have some entry in this dictionary at this delta. And if we do, it might be taller than our new taller. So we want to choose which one of those to put back into the dictionary. So we can choose the maximum of the two. So we'll choose the maximum of either this new taller or what's already in our dictionary here. If there is no entry, we will need to actually create one. So we'll use the get operation. So dp get the new taller delta, or we'll default to 0. So that's how we update this here. I'm going to drop that down. All right. So that's how we update our new deltas. Now there's a problem. We're currently iterating through all the keys in this DP. Now down here, we might be adding a new key to this DP. Now this is a big red flag. This is something you cannot do. If you're iterating through an iterable, in this case our DP, you cannot change the thing you're iterating over while you're iterating over it. That would be like trying to go through every number in an array while you're adding numbers to the array. You'll just never end. That's a problem. In fact, it won't let you even do this. So at this point, we have a problem. We cannot add new keys to our dictionary while we're iterating over it. So the way to get past this is to actually take a snapshot of this dictionary before we iterate. So we'll have some new DP, and that's going to be a dp.copy. Okay, so we have our new DP. We're taking a snapshot. Now we'll go through this DP, but instead of adding things to our current DP, we'll add it to our new DP. And again, down here, we'll probably want to use our new DP. Next, we'll be adding another new key, which is this new shorter delta. It's possible that this new shorter delta and the new taller delta are the same, which means that if we just used our old DP, we might be missing our snapshot from this DP. So we actually want to use our new DP here just to make sure that everything's on the same page. All right, so we've gone through, we've added our new taller delta. We still have not added our new shorter delta. So let's do that. So this new DP at the new shorter delta. Now this isn't the best name because this delta might not actually be shorter, like we might be taller than our tall at this point, but it's using the shorter as the base, so that's why I'm calling it the new shorter delta. All right, so what do we put at the new shorter delta? Well, again, we have to put our maximum between what's already at this point, or what is the max of our poles. Now at this point, it's a little unclear because it could be this new shorter, because we added our rod to the shorter, or it could be that the taller was still already taller than shorter plus the rod. So at this point, it could be several different options. All right, so we'll just choose the maximum of the new shorter. That's one option. It could be the taller. That's the other option. Or it could be what's already in this dictionary for this key. So that's new DP, and we'll do a get again for the new smaller or shorter delta, or 0. Okay, so these are the different options it could be at this delta. It could be the new shorter, because the new shorter minus the taller, the new shorter is taller, and so this new shorter delta is the new shorter. It could be the taller, because the new shorter is still shorter than the taller, so the shorter plus the rod was not taller than taller. Or it could be what's already in this dictionary. All right, now we've gone through all of our options. We've updated our dictionary. We have to take that dictionary and replace it. So replace our snapshot with this new DP. So we take a snapshot, we go through, we update, and then we can replace our DP with that updated snapshot. And finally, at the very end, now we've gone through all of our rods. We've gone through every rod in our rods. We've tried to update all the different possible deltas between the taller and the shorter. Now at the very end, we do have to return something. And what do we return? Well, we want to find the tallest rod that has a 0 delta. So we return our result, or our DP, at index 0. And we've already initialized it here with a 0, so we'll return 0 if we don't find anything better. All right, let's see if this works. I probably have typos, but we'll try it. No, that actually works. All right, let's submit this and see how we do. And we pass, and we do okay. So we beat 72% for runtime and 67% for memory, so that is not too bad. Now I'm using a whole bunch of sort of intermediate variables here, like taller, shorter, these new tallers. A lot of these variables are here to make it clearer to read and understand as we're going through this process. We could go through and collapse a bunch of these into either no variables, just access them directly, or we could change their names to make them shorter. We could do a bunch of different things in here. For example, this delta is just the key. We don't actually need to do this. We could just change delta here and remove this one completely. We don't need that. That's just one example. There are other things we could do in here. There's some additions that we're doing that we might not need to do. So you can check this one out. That's my advice to you. Check this one out. Again, this is 956. This is a hard problem, and I will admit I did not come up with the solution solely on my own. All right, well, that's it for me. I gotta go. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.